So let's talk about the components of variation. So let's return to the PCB Pro and its PCBA viewer measurement tool. So far, 5 operators have taken repeat measurements of distances between components on 12 circuit boards. Uh, we perform we perform the gauge INR study on their measurements and are now ready to evaluate the graphical results. The output includes several graphs, including a components of variation graph. So let's look at uh, this graph first, and use it to interpret different sources of variation in the measurement system. Remember, some variation is always present in our past. Ideally, our measurement system would be able to detect differences in past collected from the process. If the measurement system itself has little error, so the most of the variation in our measurement is the result of real differences among parts. Let's look at the components of variation graph more closely for the data collected from the PCBA viewer measurement tool. So each cluster of bars represents a specific component of variation. Gauge NR is the precision or the variation due to the measurement system. Remember, precision is composed of both repeatability and reproducibility. Show in these two components. Repeatability, shown here, is the variation observed when the same circuit board is measured multiple times by the same operator. This component is the producibility variation. This variation is observed when the same circuit board is measured by different operators. The last cluster of bars displays the part-to-part variation. This is a variation across different circuit boards. In other words, part-to-part variation is variation in the circuit boards themselves, not the measurement system. Remember, when we sample circuit boards, we choose boards that represent the entire range of possible paths. Because the sample includes boards with different distances between components, we expect to observe variation among circuit boards. So now let's look at the 4 bars within each component of variation. So what do they represent? The blue, and blue and red bars are always shown by default. The blue bar is the percentage of variation that each component contributes to the total variation. The red the red bar compares the standard deviation of each source of the total uh, each source of to total standard deviation. This is what uh, we look at when we want to compare measurement variation to the total variation. If we include a historically known standard deviation in the analysis, we also see this yellow bar. It shows us the percentage of variation of each source compared to the process variation. If we include a tolerance in the analysis, we also see this green bar. This represents the percentage of variation of each source compared to the tolerance. This is useful if we want to evaluate paths relative to specifications. So now consider the components of variation graph for the PCBA viewer data as a whole. As a whole. So what conclusion might we draw from this graph? So the total variation is primarily due to variation in circuit box, or the total variation is primarily due to variation caused by the PCBA viewer measurement system, or the total variation is divided between variation caused by the PCBA viewer measurement system and variation in the circuit box. So what is your answer? The answer is A. Is A? No, this is not a correct answer. If the most if the most of the variation were in the past were in the past, then the path-to-path cluster of bars would would be much higher than the rest, right? So how about B? B is also not a good correct answer. Okay, because if most of the variation were caused by the measurement system, then the first three clusters of bars would be much higher than the path-to-path cluster. Okay, so how about the C? Okay, C is the correct answer. So you see here, each component contributes some amount of variation to the total variation. So how about this? So is the total variation is almost if evenly divided between the measurement system and the paths themselves. This is undesirable because it suggests that the PCBA viewer measurement tool is responsible for a large amount of the variability in the measurements and is probably not adequate for the needs of PCBA Pro. So let's dig deeper. So what is the greatest source of measurement error? So according to the graph, reproducibility is the largest source of measurement errors. Remember that reproducibility is the variation observed when the same circuit board is measured by different operators. Different operators measure the same circuit board component differently. So we'll learn more about the reproducibility variation later in the chapter. So because there is too much variation in the PCBA viewer measurement system, so it is difficult to detect real differences among circuit boards. So ideally, the measurement system would be able to detect these differences, and most of the variation would result from real differences among parts. So let's review. In this lesson, we use the components of variation graph to evaluate the sources of variation that contribute to the total variation. When the measurement system has little error, so most of the variation is seen in the path-to-path component. So next, we'll look at H-bar and R-charts to evaluate path-to-path variation and the repeatability of the measurement system. Thank you for your listening. In the next lesson, we'll talk about the H-bar and R-charts.